Not Ethereum. Solidity.
Solidity.
Solidity. Builds it better.
Shout out to Anders Brownworth for making a classic demo for blockchains. So you can visit his website andersbrownsworth.com/blockchain and you can check out the demo yourself. So let's get started. First, heading to the basic block, the difficulty level Asian hash. So this is the hash used in blockchain, that is SHA-256 hash. It consists of two parts, data and hash value. This hash value is a randomly generated number which corresponds to this data, that is, which changes every time data is changed. For example, if we write, just for example, see, with every value the hash value has changed. If I delete one part, hash value has changed. It is B1561 something something blah blah blah. Then it is 7F, 5A, 9B, blah blah blah, and blah blah blah. Okay, so this part is clear. This hash corresponds to this data. With every change in data, this hash value will be changed. Next, moving to the difficulty level Caucasian, we have block, the big brother of hash, that is block. Block basically consists of four parts: a block number, a nonce number, the Brits may be happy, the data, and the hash value corresponding to this data. Okay, so with every change in data, again we can see this hash has changed. But is there any effect of nonce? No. So does this nonce value have any meaning? Yes. Basically, you can see during the time we write here, the hash value has changed. Also, the green color in the background has changed to red. Like if I write again, the hash value will be changed. It will correspond to this data. And to fix this color difference, what we'll do, we'll mine this block. Okay, mining this block is performing calculations to determine a random number which is nonce, which corresponds to this hash, which leads us to this data. In simple terms, what we are doing in mining is basically for every change in data, we are determining a new nonce, that is, this is a hit and try method. We determine a new nonce and every time we keep doing this until and unless we find the first 4 zeros in the hash value. And if we find the first 4 values in hash first 4 zeros in hash value, then we stop mining and we say this nonce value corresponds to this block. We have mined the block, that is, we have found the block which the problem statement gave us to find. Okay, next, moving on to difficulty level American, that is blockchain. It has length but no width. It is linear blockchain, so it consists of multiple blocks. Here we have block 1, 2, 3, 4, 5. Each block, now we have a new feature addition which is of previous, as you can see. The rest concept are same as the block. So we have block number, nonce, Brits, data, previous value, and a hash value. So basically what previous does here, it corresponds to the previous hash of the block which was present before it. In other words, what I am trying to say, see, in block 1, this previous value is 0, that is the initial block. So it has no links to the previous block. It is the first block, so it has no links, so it will start with 0. Then the hash value, you can see 40. Let's describe it as Z. So Z1583B. See, in block 2, the previous corresponds to Z15783B. Same. Or similarly, in hash of block 2, you can see it is Z125FAB9B. Similarly, the block 3, the previous hash value will be the same as block 2's hash value. So it's a diagonal relation. It links them together. That's why the block can propagate the information as well. Now, interesting part. Let's see. If I want to change the value in block 1 or in any other block, you know what will happen? The block will be not verified. that is, that information will in the blockchain will not be verified. So all the blocks along with the first block, all the blocks which depend on the first block, they will change. Why? Because in this case the hash value has changed and the previous hash value corresponding to them will also change simultaneously. So what to do? In this case, we will have to mine the block individually. In this mining process, this means we have to make we have to use computational power of our GPUs in determining by hit and trial the nonce value. So for each block, we have to do this concept now. Okay, so first block it is done. It will take some time because it has a hit and trial method. So we may get success directly or it may take some time. So mining each block individually. So let's fast forward this. That is why no single individual can mine the whole blockchain. If I want to change any value, I come from Islamabad and I want to change any value in any certain block, then what will happen? I have to mine all the blocks, that is make all the blocks verified, the data in the blocks verified, and transpire or transport that information to the further blocks. But in this case, what is the catch? Blockchain is pretty much visible to all, pretty much open to all, so anyone can see what is happening in any block at any time. Is there any information change? The update for that information change will be given to all the people available on the blockchain. So yeah, pretty much it is immutable. That is why we call it immutable ledger. Next, moving on to difficulty level African, we have distributed blockchains, which have both the length as well and the girth as well. So see what is happening here. In distributed blockchains, we have peers, like one blockchain will be considered as a peer A, another blockchain running parallel to it will be considered as peer B, and similarly peer C. So can you say what happens when I change any value in like any data value in any block in peer A? What will happen? Will the block 1 and 2 be affected? No. So what you can see here, as I have written this, so block 3, 4 and 5 will get affected, but there will be no effect on block 1 and 2 as their previous and hash values are the same. Now to change this, make this change verified, or to verify this change that yes, the transaction or the effect that I have chosen here is correct, what I will do, I will mine the blocks further. And can you tell me what happens to the peer B and peer C? They do not change. Basically, you can understand it for the example of a class standing in an assembly. You have class 1, class 2 and class 3 students. If any student faints, as you can see, if any student faints, the rest of the line falls along with it. But the line that is peer B and peer C, that is class 2 and class 3, they will have no effect, little to no effect. So that is why distributed blockchains are very useful in our day-to-day lives. Moving on, this was all about blockchain, how blockchain works, how distributed blockchain works. And in the next section, we'll start again with the concepts of POS, that is proof of stake, consensus protocols. So till then, keep watching the previous videos and yeah, peace.
Tylko jedno w głowie mam, koksu 5 gram, odlecieć sam w krainę zapomnienia. W głowie myśli mam, kiedy skończy się ten stan, gdy już nie będę sam, bo wiedzie biały